Pyspark is an interface for Apache Spark in Python. It is often used for large-scale data processing and machine learning. Krish Nack teaches this course.
We are going to start Apache Spark series, and specifically if I talk about Spark, we will be focusing on how we can use Spark with Python. So we are going to discuss about the library called as Pyspark. We will try to understand everything, why Spark is actually required, and probably we'll also try to cover a lot of things. There's something called as Mlib, Spark Mlib, which will basically say that how you can apply machine learning, in Apache Spark itself with the help of this Spark API called as Pyspark libraries. And apart from that, we'll also try to see in the future, once we understand the basics of the Pyspark library, how we can actually pre-process our data set, how we can use the Pyspark data frames. We'll also try to see how we can implement or how we can use Pyspark in cloud platforms like Databricks, Amazon, AWS, So all these kind of clouds we'll try to cover. And remember, Apache Spark is quite handy. Let me tell you, let me give you some of the reasons why Apache Spark is pretty much good. Because understand, suppose if you have a huge amount of data, okay, suppose if I say that I'm having 64 GB data, 128 GB data, we may have some kind of systems, standalone systems, where we can have 32 GB of RAM, probably 64 GB of RAM. Right now in the workstation that I'm working in, it has 64 GB RAM. So max to max, it can directly upload a data set of 32 GB, 48 GB, right? But what if we have a data set of 128 GB? That is the time, guys, we don't just depend on a local system. We'll try to pre-process that particular data or perform any kind of operation in distributed systems, right? Distributed system basically means that there will be multiple systems, where we can actually run this kind of jobs or processes or try to do any kind of activities that we really want. And definitely Apache Spark will actually help us to do that. And this has been pretty much amazing, and yes, people wanted this kind of videos a lot. So how we are going to go through this specific playlist is that we'll try to first of all start with the installation. We'll try to use Pyspark because that is also Apache Spark it is a Spark API with Python. When you're actually working with Python, we basically use Pyspark library, and yes, we can also use Spark with other programming languages like Java, Scala, R and all, right? And we'll try to understand from basics, how do we read a data set, how do we connect to a data source, probably how do we play with the data frames. In this Apache Spark, that is your Pyspark, also they provide you data structures like data frames, which is pretty much similar to the Pandas data frame, but yes, different kind of operations are supported over there, which we'll be looking one by one as we go ahead. And then we'll try to enter into Mlib, the Apache Spark Mlib. So basically it is called a Spark Mlib, which will actually help us to perform machine learning, where we'll be able to perform some machine learning algorithm task, where we'll be able to do regression, classification, clustering. And finally, we'll try to see how we can actually do the same operation in cloud, where I'll try to show you some examples where we will be having a huge data set. We will try to do the operation in the clusters of system, in a distributed system, and we'll try to see how we can use Spark in that, right? So all those things will basically get covered. Now, some of the advantages of Apache Spark and why it is very much famous, because it runs workloads 100 multiplied by 100 times faster. That basically means, and if you know about big data, guys, when we talk about big data, we're basically talking about huge data set, right? And there, if you have heard of this terminology called as map reduce, right? Trust me, in Apache Spark is much more faster, 100 times faster than map reduce also. Okay, and it is some of the more advantages that it is ease of use. You can write application quickly in Java, Scala, Python or R. As I said, we'll be focusing on Python, where we'll be using a library called as Pyspark. Then you can also combine SQL streaming and complex analytics. When I talk about complex analytics, I'm basically talking about this Mlib machine learning libraries that will work definitely well with the Apache Spark. And Apache Sparks can run on Hadoop, Apache Mesos, Kubernetes, standalone, in the clouds, different types of clouds, guys. When I talk about AWS, Databricks, all these things, we can definitely work, okay? And it actually runs in a cluster mode. Cluster mode basically means in a distributed mode, right? So these are some of the examples. Now, if I go with respect to which version of Pyspark Spark will be using, probably Spark 3.1.1 will be using. We'll try to work and if you just go and search for here you can see SQL and data frames and all. Here you can see Spark streaming, machine Mlib, that is called as machine learning and all, right? And apart from that, if I go and see the overview, here you can see that Apache Spark is a fast and general purpose cluster computing system. It provides high level APIs in Scala, Java and Python that makes parallel job easy to write and optimized engine that supports general competition graph. So it is basically to work with huge amount of data in short, you know, and that is pretty much handy. We'll try to work. Now if I go and search for this Spark in Python, you know, this page will get opened, and this things we'll try to discuss how to install it, and in this video we'll try to install the Pyspark library. If I talk about Pyspark library, you'll be able to see that Pyspark library is pretty much amazing. This library is if you really want to work Spark, if you want to work this Spark functionality with Python, you basically use this specific library. And let's proceed and let's try to see that how we can quickly install the specific libraries and check out like what all things we can actually do. Okay, so all these things we'll try to see. So let's begin. Please make sure that you create a new environment when you're working with Pyspark. So I've created a new environment called as my env. Here, first of all, I'll try to install the Pyspark library. So I'll just write pip install Pyspark. Okay, and let's see. In this, we'll focus on installation. We'll focus on reading some data sets and try to see that what all things we can actually do. Okay, and after doing this, what we can actually do is that you can see that our Pyspark has been installed. In order to check whether the installation is perfect or not, I'll just write import Pyspark. So this looks perfectly fine. It is working. You know, we are able to see that the Pyspark is basically installed properly. Now you may be facing some kind of problems, guys, with respect to Pyspark. So that is the reason why I'm telling you create a new environment. If you're facing some kind of issue, just let me know what is the error that you're getting, probably writing in the comment section. Okay, now let's do one thing. I'll just open Excel sheet. Okay, and probably I'll just try to create some data sets. I'll say name, probably I'll just say name and age, right? And suppose my name over here that I'm going to write is Krish, and I'll say 31. I'm going to say Sudhanshu, right? Sudhanshu. I will just say okay, 30, and probably I'll just write some more names like Sunny. Probably I'll also give the data as 29. So this 3 data, we'll just try to see how we can read this specific file. Okay, so I'm just going to save it. Let's see. I'll save it in the same location where my Jupyter notebook is, guys. I've created a folder, I guess. You can save it in any location where your notebook file is open, right? So it is not necessary. I'm just making sure that you don't see any of my files. Okay, and I'm just saving it. Okay, I'm saving it as test1. Here you can see I'm saving it as test1.csv. So I'll save it. Let's keep this particular file saved. Okay, now if I probably want to you know, read with the pandas, so what we write pd.read_csv, right? And I basically use this particular data sets called as test1.csv, right? So when I am executing this, here you will be able to see the specific information. Now when I really want to work with Pyspark, always first of all remember we need to start a Spark session. And in order to start a Spark session, first of all let me create some more fields. Just see this, just follow these particular steps with respect to creating a Spark session. So I'll write from Pyspark.sql import Spark session. Okay, and then I'll execute this. You can see that it is executing fine. Then I'll write, sorry, I don't know what has opened. So I'll create a variable called as Spark, and probably I'll use the Spark session dot builder. and I'll say app name, and here I'll just give my session name. Okay, so it will be like practice. Suppose I'm practicing these things, and then I can say get or create. So when I actually execute this, you'll be able to see a Spark session will get created. And if you're executing for the first time, it will probably take some amount of time. Other than that, if you have executed multiple times, then you'll be able to work it. Now here you can definitely see that in this, when you're executing in a local, there will always be only one cluster. But when you are actually working in a cloud, you can create multiple clusters and instances. Okay, so the Spark version that you will be using is v3.1.1. Here you can see that this is basically present in the master. When probably you will be working in multiple instances, there you'll be seeing masters and cluster 1, cluster 2, all those kind of information. Okay, so this is with respect to Spark. Now let's I'll just write df of Pyspark, where I will try to read a data set with respect to Spark. Okay, now in order to read a data set, what I can write like this: Spark dot read dot. There is a lot of options like CSV, format, JDBC, ParQ, schema, table, text. A lot of options there. So here we are going to take CSV, and here I'm just going to write tips1 dot CSV, right? And if I just try to execute it, here I'm getting some error saying that this particular file does not exist. Let me see. I think this file is present. Just let me see, guys. Why this is not getting executed? Tips1 df file open. Here I can see test1.csv. Okay, sorry, I did not write the CSV file, I guess. Test1.csv. Okay, this has now worked. Now if I go and see dy.pyspark, it is showing this two strings, right? This two columns, cu0 and c1. Now here you can see that, guys, I've created this particular CSV file, right? And it is just taking this AB as a default column probably. So it is saying c0 and c1. So what we can actually do is that, and probably if you really want to see your entire data set, you can basically see like this. df underscore pyspark dot show. Here you will be able to see name and age. Krish, this information is there. I really want to make my column name or age as my main column, right? But when I'm directly reading this CSV file, probably we are getting underscore c0 underscore c1. So in order to solve this, what I will do is that we have a different technique. So I'll write spark dot read dot option. There is something called as option, and inside this option, what you can basically give is that there'll be an option with respect to header, I guess. See, there'll be something like key value that you will be providing in option. So what you can do, you can just write header comma true. So whatever value, the first column, first row value will be there, that will be considered as your header. And if I write CSV with respect to test1, now I'm just going to read this test1 dataset, test1.csv. Now once I execute this, here you'll be able to see that I'm able to get now name string, age string. Okay, but let's see our complete data set. So here if I execute this now, I'll be able to see the entire data set with this particular columns. Okay, so let me just quickly save this in my df underscore pyspark. Okay, and now let's go and see the type of df underscore pyspark. Okay, now when I execute this, here you'll be able to see, guys, when I was reading this df, right, if I go and see the type of this with the help of pandas, here you'll be able to see that this is pandas.core.frame.dataframe. But here you'll be seeing that when you are reading this particular data set, it is of type pyspark.sql.dataframe.dataframe. Yes, so that is pandas dataframe, this is sql.dataframe.dataframe. Yes, most of the APIs are almost same, the functionalities are same. There are a lot of things that we will be learning as we go ahead. But if I quickly want to see my, probably I don't know whether head will work. Let's see. Yes, head is also working. So if I use dot head, probably you'll be able to see the rows information are basically shown over here. Now if I really want to see the more information regarding my columns, I will be able to use something called as print schema. Okay, now in this print schema is just like df.info, which will actually tell about your columns, like name is string and age is string. Okay, so all these are some basic operations that you have actually done after installation. Again, the main thing why I'm focusing on this is that just try to install this Pyspark and keep it ready. For my next session, I will be trying to show you how we can change the data type, how we can work with data frames, how we can actually do data pre-processing, how we can handle null values, missing values, how we can delete the columns, how we can do various things. All those things will basically we'll be discussing over there, how to drop columns and all. So guys, we will be continuing the Pyspark series, and in this tutorial we are actually going to see what are Pyspark data frames. We'll try to read the data set, check the data types of the columns. We basically say in Pyspark called a schema. Then we'll see that how we can select the columns and do indexing. We'll see describe functionality that we have similar to pandas, and then we'll try to see that how we can add new columns and probably drop columns. Now this is just the part 1, so let me just write it down as part 1, because after this there will also be one more part. Why this video will be important? Because in Pyspark also, if you're planning to apply Mlib, the machine learning libraries, you really need to do data pre-processing initially. Probably in the part 2 we'll try to see how to handle missing values and all. We'll try to see how to alter the rows, how we can probably put a filter condition and all, right? So let's proceed. Before going ahead, what I'm going to do is that we will first of all I have a data set called as test1. So I've taken 3 columns. One is name, age and experience. And then I have a data set like Krish 3110, like this, Sudhanshu, Sunny, right? So this is some data set which I have saved in the same location. Now what I'm going to do, first of all, as usual, the first step with respect to Pyspark is to build the Pyspark session. Now in order to build the Pyspark session, I will write the code line by line. So please make sure that you also do along with me. It will definitely be helpful. So I'm going to write from Pyspark.sql import Spark session, and then I will create a variable. Then I'll start to create a variable regarding my session. So I'll write Spark is equal to Spark session dot, we basically write builder dot app name, and here I'm just going to give my app name as practice. I can just say, or let me write data frame practice or data frame, right? Something like this, since we are practicing data frame dot get or create function, and this is how you actually start a session. So once and again, if you're executing for the first time, it will take some time, otherwise it is perfect to go. So here is my entire Spark. It is running in memory, the version that it is running over here, and obviously when you're running in the local, you basically have one master node, okay, and the app name is data frame. So to begin with, we'll try to read the data set again. So let's read the data set. Now reading the data set, I have already shown you multiple ways. One is through read option, one is to and since this is a CSV file, we'll try to read it. First option, we'll try to see how we can actually read it, and then I'll show you multiple ways of reading it. Okay, so I'll write spark dot read dot options, and here in this option we basically say key value, right? So here I'll just make it as header is equal to true, so that it should be considering my first row as the header, and here I'll write it as header as true dot CSV. Inside the CSV I'll give my dataset name, that is called as test1.csv, right? Now when I execute this, probably I think you'll be able to see the dataset. So here you are able to see that, okay, it is a data frame and you have features like name, age, experience, right? So if I want to see the complete data set, I'll just write dot show. So here is my entire data set over here. Very clearly I can see it. Now let me just save this in a variable called as df_Pyspark. Okay, so here is my entire data sets. Now first thing, how do we check the schema? Let's check the schema. Okay, schema basically means the data types, like how we write in pandas df.info. Similarly we can write over here. So here you'll be able to see that I have written df_Pyspark.print. I think it should work. Print schema. Oh, none type has spring schema. Oh, sorry. So I had written dot showed and saved in a variable. I'll remove this dot show. Let me execute it once again. And now if I write print schema, here you'll be able to see name, age and experience. But by default, it is taking a string. Even though in my Excel sheet, what we have done is that we have written values. Probably this should be string, this should be integers, then this should be integers. But why it is taking it as string? The reason it is probably taking as string, guys, because by default, unless and until we don't give one more option in CSV, in this CSV we have one option called as infer schema. Okay, if I don't make this as true, right, it will by default consider all the features as in the string values. So I'll execute this now, and now if I go and see def underscore pyspark.print schema, you'll be able to see that I'm getting name as string, age as integer, experience as integer, and nullable is equal to true. That basically means it can have null values. Okay, so this is one way of reading it. One more way I'll try to show you, which is pretty much simple. So I can include both header and infer schema in one thing itself. So I'll write def underscore pyspark is equal to spark.read .csv, and inside this CSV, first of all I'll provide my test file CSV. Okay, and then here I will go ahead and write header probably is equal to true, and I can write infer schema is equal to true. So when I write like this, and if I write def underscore pyspark.show, here you'll be able to see all my data set. Okay, so here is my entire data set. Now if I go and see and execute this schema again, it will probably give me the same way like how we had over here. Okay, so here you can see name is equal to string, age is equal to integer, experience integer into integer. Perfect. So what all things we have done, we have understood about this one. And right, if I go and see the type of this, this is basically a data frame. Pandas also have a data frame. So if somebody asks you in an interview what is a data frame, you can basically say that data frame is a data structures, because inside this you can perform various kind of operations. So this is also one kind of data structures. Okay, so what all things we have actually done, I've given you introduction of data frame, reading the data set, now checking the data types of the column. In order to check the data types of the column, we have already just written print schema. Okay, now one more thing that I can do after this, let's see, selecting columns and indexing. First of all, let's understand what all columns are basically present, how you can get all the column names. So in order to get the column names, you can just write dot columns. Okay, and when you execute over here, you'll be able to get the column name like name, age, experience. Perfect, this is perfectly fine. Now this is my def. Now suppose if I want to pick up some head elements also, I will be able to pick up, because in pandas also you have an head. Suppose I see I want to get the top 3 records, I will be getting in this particular format, in the list format. Usually in pandas when we are using, we usually get in a data frame format. So here you'll be seeing the combination of name, age and experience. Okay, like this. This is my first row, this is my second row, this is my third row. Okay, now coming to the next thing that we are going to discuss now, how do I select a column? I probably want to pick up a column and see all the elements, right, like how we do it in pandas. So first of all, let me just write it like this, pyspark.show. Here you'll be able to see all the columns. Now if I really want to pick up only name column, okay, so how do I do it? Okay, let's actually see. Now in order to pick up the name column, there is very simple functionality that we'll write, which is called as pyspark.select, and here I will just give my name column. Now once I execute this, you'll be able to see that return type is data frame. Okay, the return type is data frame and name is basically a string. Now if I write dot show, I will be able to see the entire column. Okay, so when I do this, I'll be able to see this, and if I try to find the type of this, so sorry, if I remove this dot show and see the type of this is basically a data frame. Pyspark.sql.dataframe.dataframe, not pandas.dataframe. Okay, pretty much simple. Now suppose I want to pick up multiple rows, like multiple columns, like I want to pick up name and experience, probably 2 columns I want to pick up. So what I'll do, I'll just make one changes here. Initially I was providing my one column name like this. After this, what I'll do, I will provide another column which is like experience, and I'll execute this. Now once I execute this over here, you can see that, guys, I'm getting a data frame with 2 features, one is name and experience. Now if I go and write dot show, here you'll be able to see all my elements are basically present inside this particular data frame. Pretty much simple, guys. How do you select multiple rows? And yes, here slicing definitely will not work, because I tried doing slicing, it was not working. Okay, and again, whenever you have any kind of concerns, always try to see the documentation, the Pyspark documentation. Pretty much simple. Okay, this is one way that how we can actually select the columns and probably see the rows. Okay, now let's show you if I just want to pick up, there is also one way like this. See, if I write df of Pyspark of name, if I execute this, here you'll be able to see column name. The return type will be column over here if I'm directly picking, because in pandas we directly pick like this, right? And when we have this kind of columns, definitely we'll just not we are just able to understand what this particular feature, it is basically a column, it is saying. Okay, nothing more. We won't be able to get the data. See, there'll be no show function. It will be saying that it is basically an error. So usually what we do whenever we want to get or pick up any kind of columns and try to see it, we basically need to select using this particular select operation, which is my function. Okay, so these all things have been done, guys. What we try to understand. Now let's see how we can check the data types. So there is a functionality which is called as D types. So here you will be able to see name is equal to string, age is equal to int, experience is equal to int. And again, D types is pretty much similar because we also use this in pandas. Okay, most of the functionalities are similar to pandas, guys. So what are things we have actually done? Let's see. Pyspark data frame, reading the data set, checking the data type, selecting columns and indexing. Check the describe option similar to pandas. So we can also check out the describe options. So let's see. Pyspark dot describe, and if I execute this, you'll be able to see it will give you a data frame. Summary is equal to string, this information is there. Now when I write dot show, okay, you'll be able to see all this. This is basically in the form of data frame. You may be thinking why this null value is coming, mean and standard deviation, because understand even in this it will take the string column also, basically the values that are having the data type as string. Over here obviously you don't have anything, so min and max is basically taken on the index because in the second index you'll be able to see Krish is there, and after that Sunny is there, okay, in the fourth index, and remaining all this information are actually present. Okay, so this is basically the same like the describe options that we had actually seen probably in our pandas, right? So similarly we have actually done that. Okay, so describe option is also done. So now let's go and see adding columns, dropping columns. Okay, so adding columns and dropping columns, this is very much simple, guys. If we need to add the columns, so I'm just going to write the comment over here, adding columns in data frame, and this data frame is Pyspark data frame. Okay, now in order to add the column, so we have an amazing function which is called as df Pyspark dot, there is something called as with column. Okay, now this with column, if I see the functionality, it returns a new data frame by adding a class or replacing the existing column that has the same name. Okay, so here the first parameter that I'm going to give is my column name. Suppose I want to pick up, let's see, I'll pick up experience. So I'll say experience, okay, and probably this will be my new column after 2 years. What will happen if experience after 2 years? Initially the candidate is 10 years experience. After 2 years it will become 12, right? So we'll try to put now the value. This is my new column name and what value it should have. So for that I'll write df Pyspark, and here I'll say probably I'll take that same experience. I will multiply it by I will add by 2, because after 2 years the experience will get added by 2. Just I am taking one way of actually solving this. I can put any values I want, guys. It is up to you. Okay, and you can actually check it out. Okay, now after this, this is only the 2 things that is required, and now if I execute it, you'll be able to see that some operation will happen, and now you in this data frame you have 1, 2, 3 and 4 feature. If I want to see the complete data set, I can write dot show. Once I execute it, now here we'll be seeing that experience after 2 years is nothing but 12, 10, 66, because 10 plus 2, 12 you have. Very simple, guys. And this is what with column is basically told as, and you can also do different things with respect to this. So this is how you can add a column in a data frame. And again, guys, this is not an in-place operation. You basically need to assign it to a variable in order to get reflected. Suppose if I want to get it reflected, I really need to assign like this. And here now if I go and see my, sorry, first of all let me remove this show. The show will not give us proper result. Okay, has no attribute with column. Okay, sorry. So this there was a problem with respect to this. I'll read this data set because I replaced it completely, right? Now I will execute it once again. Now is fine. Now if I go and write dot show, here you will be able to see the elements all properly given. Now this was with respect to adding the columns with Dataframe. Now I probably need to drop the columns also. So drop the columns. Let's see how we can actually drop the columns. Dropping the columns is pretty much simple, like how we usually drop. This drop functionality by default take column names. You can give a list of columns, you can give a single column name. So suppose I'll say experience after 2 years. I want to drop this because who knows after 2 years what will happen. So let's drop this. In order to drop this, just execute like this and just go and see dot show. Here you will be able to find out without that specific column. Again, this is not an in-place operation. You need to assign it to a variable. Very much simple. So let me just assign it to a variable is equal to, and please make sure that you remove this dot show. Dot show is the functionality, right? Now if I write this dot show, here you'll be able to see all the elements. Good. Now let's go ahead and see how to rename the column. So we are just doing this, guys, because you really need to be very good at data pre-processing. Okay, so I'll write dot, and there is another function which is called as with column renamed. Okay, now in this you just give your existing and the new column name. Suppose I have my existing column name over here. I'll say name and I'll say new name. Okay, and just execute it. And now if I go and just write dot show and try to see the elements, here you'll be able to see instead of name there will be something called as new name, right? Now this is what I had to actually discuss. I am just writing one more point over here. We have also discussed about renaming columns, right? And yes, this is just the part 1 of data frames. In the part 2 we'll try to do something called as filter operation, and in filter operation we'll try to see various operations, guys. It will be pretty much amazing. You'll be able to learn a lot. And probably this is the tutorial 3, which is the part 3 with respect to data frame operations. In this particular video we are going to see how we can handle missing values, null values, you know. So in short, this many things we'll actually try to do. We'll see how to drop columns, we'll see how to drop rows, then we'll see when we are dropping rows, probably based on a null values we'll try to drop a rows, and then we'll try to see what are the various parameters in dropping functionalities and handling missing value by mean, median or mode. Okay, so here I'm just going to write it as mean, median and mode probably, right? So all these things we are actually going to see. Again, the main thing is that I really want to show you that how we can handle the missing values. This is pretty much important because in pandas and all also we try to do this. In sklearn we have some kind of imputer function. So let's proceed. Whenever we usually start a Pyspark, whenever we are working with Pyspark, we really need to start a Pyspark session. So I hope till now you all are familiar. So I'll write for pyspark.sql. I'm going to import Spark session. Okay, and then I'm going to create a variable with Spark, and then here I'm going to write Spark session dot builder dot app name. Okay, dot app name. Again, let me just keep this app name as practice. Okay, because I'm just practicing things. And then I write get or create and just execute this. So probably it will take some time to get executed. Yes, it has got executed fine. Now for this I've just created a very simple data set which looks like this. I have a column like name, age, experience, salary. So these are all my names, all the candidate names, and probably there are some values which are left blank. Here you can see some values are left blank. So we'll try to see how to probably drop a null values or how to handle this particular missing values and all. Okay, so let's proceed. So first of all, in order to read the data set, I'll just write spark.read.csv, and here I'm just going to use the CSV file name test2.csv, and it is saved in the same location where this particular file is. Anyhow, I'll be providing you in this GitHub also, and I'm going to use header is equal to true, and probably there is also infer schema is equal to true, so that I'll be able to get the data set properly. So probably when I'm reading this, you'll be able to see this is my data frame that I'm actually getting. If you want to see the entire data set, this will be like use dot show, and this is your entire data set. Here you are having null values and all. Perfect. So let me do one thing. Let me just save this in a variable. So I'll write df underscore Pyspark. So if I go and now check dot show, this is my entire data set. Okay, Perfect. We are pretty much good till here. We are working fine with respect to this. We know we have actually read some kind of data set also. Now, probably first let's start. How do we drop the columns? Dropping the columns is very, very simple, guys. Suppose I want to drop name column, then I just use df.drop and provide my column name like this, right? So column, right? Column name. Suppose I'll write df.pyspark, and here column name will be name. So let me write it as name, and I can basically go and check out my dot show. Then you'll be able to see all the features that are actually present. This is pretty much simple, which I also showed you probably in the previous session also. Okay, and this is how it is basically done, basically dropping your feature or columns, but our main focus is dropping the nan values. So right now let me just write df.pyspark.show. So this is my data set, right? Now let's see how to drop this specific rows based on the null values. So over here I'll just use df.pyspark.na. okay, there is something called as na, and then you have drop, fill and replace. So first of all I'll start with drop. Now inside this particular drop, always remember, if I don't give anything, okay, and just execute it, here you'll be able to see wherever there is a null values, those all rows will get deleted. So here you'll be seeing that this last 3 rows are not present, right? So here you can see till Shubham this particular value is present, remaining all the rows have been removed. Perfect, right? So not a problem at all. So here you, in short, what you're doing is that whenever you use .na.drop, it is just going to drop wherever, it is going to drop those rows wherever nan values are actually present or null values are actually present. Okay, perfect. This much is fine. If I go and search in the drop, there are 2 main features. One is how and one is threshold, and then one is subset. So let's try to understand this particular features. Now first I will start with how. Any is equal to how. I'll just write like this. Okay. So suppose if I write df.pyspark.na.drop, and if my how, the how value can have 2 values. One is any, one is all. Okay, one is any, one is all. Any, if the value selected as any, drop a row if it contains any nulls, like even though there is just one null, okay, one null, or there is 2 nulls, or there is entire nulls, you know, then by default it is going to get dropped. Okay, but how is equal to all. When do we use all? That basically means, suppose if in your feature you have, suppose if in your row you have all the values as null, in this case you have 36 one value, this will not get dropped. But if in a record you have all the values and null, then only it will get dropped. Okay, so let's see whether this will work or not. Definitely it's not going to work, because I know all, at least one values are at least there. See over here, one values, one value, one non-null value is always there, right? If I'm using how is equal to all, it is going to drop those records which is having completely null. By default, this how value should be having any, right? So by default it is any. Any basically says that whether there is 1 null or 2 null, you are just going to drop it, drop those specific records, right? Pretty much simple. This was what how was. Now let's go ahead and try to understand with respect to threshold. What is this threshold? I'll tell you what is this threshold. Now let me just use this. Okay, I know how is any, but there is another one more option called as thresh. Now in thresh, what we do is that, suppose if I write, let's keep the threshold as 2. It basically says that, suppose over here in this particular case, if the threshold value is 2, okay, let's first of all execute it. You'll be able to see that the last column has got deleted over here. Okay, last row has got deleted. Why it has got deleted? Because we have kept the threshold value as 2. It says that at least 2 non-null values should be present. Okay, at least 2 non-null values. Now here you have 2 non-null values like Mahesh and 40,000. Okay, here you just have 1 non-null values. So because of that, it got deleted. Suppose if you had 2 non-null values over here, see 34 and 10, this is not got deleted. This is same over here, 3410, right? 3410, you have, if I go and show you 3410 over here and 38,000. At least here you had 3 non-null values. Here you had 2 non-null values. So here, whenever we give some threshold value as 2, that basically means it will go and check whether in that specific row at least 2 non-null values are there. If it is there, it is just going to keep that row, otherwise it is just going to delete it. That is what you can do. You can also check out with 1. So if I go and see 1, then you can see that all these particular rows are there, because it will just go and check, okay, here one non values are there, here it is there. If I make it as 3, okay, let's see what it will come. Now here you can see at least this is there, remaining all has been deleted, right? See over here you had only 2 non values, here also here you had 3, so this is there, 34, 10, 38,000 and null. So here you can see the value. That is the understanding with respect to threshold. Now let's go ahead with the another one, which is called as subset. So here I'm just going to write it as subset, because this is the third parameter inside my drop feature. And remember, these all features are pretty much simple with respect to, if you have worked with pandas, the same thing we are working over here. Subset. In the subset, we can actually provide, suppose I'll say in the subset, let's remove threshold. I don't want to keep any threshold. Let's say I just want to drop nan values only from a specific column, probably only from experience column. Then I can basically give it as a subset. So from the experience column, you can see that wherever there was nan values in the records, all those, that whole record has been deleted, right? So like this you can apply with respect to this. Suppose you want to apply it in age, you can also apply this, right? Wherever there was nan values, that whole record has got deleted in the age column also. So this is with respect to subset. So I hope you are getting an idea, guys. This is pretty much good, because the same thing we are trying to do, right? We are actually trying to apply whatever things we actually did in pandas, and this is very, very handy when you are working with missing data. Okay. Let's go with the next thing. Now let's go and fill the missing value, filling the missing value. Now in order to fill the missing value, again I'll be using df Pyspark dot fill dot na dot fill, okay, and inside this fill will take 2 parameters. One is value and the one is subset. Okay. Now suppose if I go and give value like this, suppose I say missing value, and if I go and write dot show, then what it is going to do, wherever there is a nan value, it is just going to replace with missing values. So here you can see, here the null value was there, so missing value, missing value, missing value, missing value. Suppose if you really want to perform this missing value handling in only a specific column, then you can basically write your column name also like this. So this will be my subset. Okay. I can also give multiple records like this. See, I can also give multiple records like experience, comma, probably age, comma, age in list, right? When I give like this, then this kind of functionality will happen in 2 columns, right? Pretty much simple. So guys, now next step, what we are going to do is that we are going to take a specific column, and probably we are going to handle the missing values with the help of mean of that specific column or median of that specific column. So right now, if I go and check out my df.pyspark here, if I go and see my dot show value, this is my entire data set over here. Now what I'm going to do is that I'm going to take this particular experience column and probably replace the null values with the mean of the experience itself. So in order to do this, I'm going to use an imputer function. And guys, if you know about imputer function, we basically use that with the help of sklearn also. In Pyspark also we have an imputer function. So I'm just going to copy and paste the code over here to make it very, very much simple. From pyspark.ml.feature import imputer. Here I'm just going to give my input columns, that is age, experience, salary. Probably I want to apply for every column over here. And then I'm just saying that for age, experience, salary, I'm just going to find out this dot format dot c output columns. And then I'm going to keep the strategy as mean. You can also change the strategy as median, mode, and everything. So I'll execute this. This has got executed fine. And then we are just going to write fit and transform. So imputer.fit df of pyspark.transform. So once I execute this, guys, here you'll be able to see that we are going to create multiple columns with underscore imputed as this name. So here you can see age underscore imputed. In short, what we have done, we have tried some kind of mean functionality over here. That basically means the null value has been replaced by mean. So over here you can see this null value is replaced by 28. Similarly, this 2 null value is replaced with 10 and 5. This is what is the experience imputed column. Over here you'll be seeing that wherever there is a null value, it is being replaced by the mean of the experience column, the mean of the age column, and mean of the salary column. And this way you'll be able to do it. If you really want to go ahead with median, just go and change this mean to median and just try to execute it. Here now you'll be able to see the median value, and here is your initial null columns which has, here are the columns which has null values, and here are all the columns which has basically the imputed values, right, with respect to mean, median. So guys, today we are in the tutorial 4 of Pyspark data frames, and here in this particular video we are going to discuss about filter operation. A filter operation is pretty much important for data pre-processing technique. If you want to retrieve some of the records based on some kind of conditions, some kind of Boolean conditions, we can definitely do that with the help of filter operation. Now guys, please make sure that you follow this particular playlist with respect to Pyspark. I will be uploading more and more videos as we go ahead. And remember one more thing, there was a lot of complaint from people telling to upload SQL with Python. Don't worry, parallelly I'll start uploading SQL with Python. I'm extremely sorry because of some delay, because I was doing some kind of work, busy with something, but I'll make sure that I'll try to upload all the videos. So parallelly SQL with Python will also get uploaded. So let's proceed. Now first of all, let me go and make some cell. Now today for this I have taken a data set, a small data set which is called as test1.csv. Here I have some data set like name, age, experience and salary, and I'm just going to use this and try to show you some of the example with respect to filter operation. Initially, whenever you want to work with Pyspark, you have to make sure that you install all the libraries. So I'm going to use pyspark.sql import Spark session, and this will actually help us to create a Spark session, right? And that is the first step whenever we want to basically work with Pyspark, right? So we'll be using spark session.builder.app name. Then I'm just going to create my app name as Dataframe and basically write get or create function, which will actually help me to quickly create a Spark session. I think this is pretty much familiar with every one of you. Now let's proceed and let's try to read a specific data set. So over here, what I'm going to do, I'm just going to create a variable df underscore Pyspark, and I'm going to use the Spark variable dot read or dot csv, and here I'm just going to consider my data set test1 dot csv, and here I'm just going to make sure that we have this particular option selected, header is equal to true and infer schema is equal to true. I think this all I've actually explained you. Then if I write df.pyspark.show, here you'll be able to see your data set. Okay, so it is reading. Let's see how we'll get the output. So this is my entire output. Now guys, as I showed you that we will be working on filter operation, and we'll try to retrieve some of the records based on some conditions. Remember, filters also are available in pandas, but there you try to write in a different way. Let me just show you how we can perform filter operation by using Pyspark. Okay, so filter operations, let me make this as a markdown so it looks big, it looks amazing. Let me make some more cells. Perfect. Now first step, how do I do a filter operation? Suppose I want to find out salary of the people who less than probably 20,000. Okay, less than or equal to 20,000. I can write like that, less than or equal to 20,000. Now for this, there are two ways how we can write it. First way, I'll just try to use the filter operation. So you have like dot filter, and here you just have to specify the condition that you want. Suppose I'll write salary is less than or equal to 20,000. Remember, this salary should be the same name of the column over here, right? And when I write dot show, you will be able to see this specific records, and you'll be able to see, okay, less than or equal to 20,000 is this four people, Sunny, Paul, Harshan, Shubham. Here you'll be able to see all these things along with the experience, right? Now this is one way. Probably I just want to pick up, after putting this particular condition, I want to pick up two columns. So what I can do, I can use this, and then I can basically write dot select, and here I'm going to specify my name. Probably I want the name and age, name comma age. So dot show, I'll do this. Now this is how you can actually do it. Again, over here you can see that name underscore age is actually there, and you are able to get that specific information. After this, probably I want to do some other operation. You can actually do less than, greater than, whatever things you want. Probably I want to put two different conditions. Then how should I put it? Let's see for that also. So I'll write df Pyspark dot filter, and here I am going to specify my first condition. Suppose this is one way. This is one way by using filter operation also, guys. And this conditions that I'm writing, I can also write something like this. See this. Suppose if I write df Pyspark of salary, suppose salary is less than or equal to 20,000. I can also write like this. I will also be able to get the same output. So here you'll be able to see the same output over here. Now suppose I want to write multiple conditions. How do I write? It's very simple. I will take this. This is this is one of my condition. So I'm just going to use this condition, and I can also use an AND operation, you know. So I'll say AND or any kind of operation that you want. Probably I want to say that df underscore Pyspark salary is less than or equal to 20,000, 20,000, and probably I want a df Pyspark of salary greater than or equal to 15,000. So I'll be able to get all those specific records. Okay. And again, I'll try to put this in another brackets. Make sure that you do this, otherwise you'll be getting an error. Okay. Very, very simple, guys. So let's see how I've actually written. It is something like this: df underscore Pyspark dot filter, df for Pyspark of salary is less than or equal to 20,000, greater than or equal to 15,000. If I execute, you'll be able to see between 15,000 to 20,000. You'll be able to find out. You can also write or, then you'll be able to get all the different values. Now this is a kind of filter operation that you can basically specify. Remember, this will be pretty much handy when you are probably retrieving some of the records with respect to any kind of data sets, and you can try different things. See, this is one way where you are actually directly providing your column name and putting a condition internally. This Pyspark data frame understands it, and you'll be able to get the output, right? So yes, this was it all about this particular video. I hope you like it. I hope you like this particular filter operation. Just try to do it from your side. Okay, one more operation is basically pending. I can also write like this. See this, everybody. I can basically say that, okay, probably I can use this operation, which is called as not operation. Let's see how this not operation will be coming. Okay, basically the inverse condition operation, we basically say. So I'll be using this, okay, and this, and inside this I can put a not condition, which like this. So I'll say this is a not of df of Pyspark salary is less than or equal to 20,000. So anything that is greater than 20,000 will be given over here. Okay, so inverse operation, you can say inverse filter operation. Guys, we will be continuing the Pyspark series, and in this particular video we are going to see group by and aggregate function. Already I have actually created somewhere around 4 tutorials on Pyspark. This is basically the fit tutorial, and again this is a part of a data frame. Why we should actually use group by and aggregate functions, again for doing some kind of data pre-processing. So let's begin. For this particular data set, for this particular problem, I've created a data set which has 3 features like name, departments, and salary, and you have some of the data like Krish, data science, salary, right? Something like this. So over here, in short, if I want to basically understand about this particular data set, there are some departments probably where Krish and other people teach, and based on different departments, they get a different salary. So let's see how we can perform different group by and aggregate functions, and see how we can pre-process or how we can get some or retrieve some kind of results from this particular data. So to begin with, what we are going to do, we are first of all going to import Pyspark SQL import Spark session. As usual, we have to create a Spark session. So after this, what we have to do, I'll create a Spark variable. So I'll use Spark session dot builder dot app name. I think everybody must be familiar with this, but again I'm trying to show you this one. So let me write it as aggregate dot get or create. So now I've actually created a Spark session. Okay, probably this will take some time. Now if I go and check out my Spark variable, so here is your entire information, okay, with respect to this particular Spark variable. Now let's go ahead and try to read the data set. Now I will just write df underscore Pyspark, and then here I'll write spark dot read dot csv. The CSV file name is basically test3.csv, and remember I'll be giving this particular CSV file in the GitHub also, and then I'll be using header is equal to true, comma, infer schema is equal to true. Now this is my df underscore Pyspark. Now what I'll do in the next statement, I will write df underscore Pyspark dot show, right? Now here you'll be able to see that I'm actually being able to see all the data sets. Here I have name, departments and salary on all this particular information. If I really want to see the schema or the columns, like which all columns where it belongs to, just like a data types, I can definitely use df underscore Pyspark dot print schema, right? And now here you can see name is a string, department is string, and salary is basically an integer. Okay, now let's perform some group by operation. First we'll start by group by operation. Probably I want to group by name and probably try to see what will be the mean average salary, you know, or what. Suppose let's take a specific example over here. So I'll write df dot underscore Pyspark dot group by. Suppose I want to go and check who is having the maximum salary out of all these people that are present in this particular data set. So I'll first of all group by name. If I execute this, you can see that we will be getting a return type of group data at some specific memory location. And you should always know that, guys, group by and aggregate functions works together. That basically means first of all we need to apply a group by functionality, and then we need to apply an aggregate function. So aggregate function, if you really want to check, just press dot and press tab. So here you'll be able to see a lot of different function examples like aggregate, average, count, max, mean, pivot, and many more, right? Now what I'm going to do, I'm just going to use this dot sum because I really need to find which is the maximum salary from out of all this particular employees, who is having the maximum salary. So here I'll say dot sum, and if I execute it, you'll be able to see that we are getting a SQL.DataFrame which has name and sum of salary. This is very much important, guys, sum of salary, because I really want to have the sum of the salary. Remember, we cannot apply sum on the string, so that is the reason it has not done over here. It is just giving you the name because we have group by name, and this dot sum will just get applied on this particular salary. Now if I go and write dot show, here you will be able to see Sudhanshu over here is having the highest salary of 35,000, Sunny has 12,000, Krish has 19,000, Mahesh has 7,000. So if you go and see over here, Sudhanshu is basically present here, here, and in big data. So overall his salary should be 35,000 if you compute it. Similarly, you can go and compute my salary over here over here by just calculating this, and then you can also compute Sunny salary, and you can also see Mahesh salary. So this is one, just an example. So here I'll just write, we have grouped to find the maximum salary, and definitely over here from this entire observation we can retrieve that Sudhanshu is having the highest salary. Okay, now let's go to one more step ahead. Now we'll try to group by departments to find out which department gives maximum salary. Okay, we are going to do a group by departments which gives maximum salary. Suppose this is my requirement. Okay, and different types of requirement may come. I'm just trying to show you some examples. So I'm just going to copy this I'm going to use this department. Okay, and then I'm basically going to say dot sum dot show. If I execute it, let me see, department is a wrong column name, so I'll write departments. It is departments, so let me write S. Now if I go and see, IoT over here gives a salary around 15,000 to this employees, to all the employees, right, combined, because we are doing the sum. Big data gives somewhere around 15,000. Data science gives somewhere around 43,000. Now suppose if I go and see big data over here, 4,000, 4,000, 8,000, 8,000 and 13,000, 13,000, 15,000. So I hope I'm getting, yes, big data is actually giving us 15,000. So you can go and calculate it. Suppose if you want to find out the mean, you can also find out the mean. Okay, so let me just write it over here, just copy this entire thing, paste it over here, and let me write instead of sum, I'll try to write mean. So by default, the mean salary here, you can see that for a particular employee somewhere for IoT it is 7,500, because this mean will be based on how many number of people are working in the department, right? So like this you can actually find out. Now I can also check one more thing, guys. I can copy this, I can try to find out how many number of employees are actually working based on the department. So I can use dot count, and then if I go and execute this, probably this is a method. Okay, now here you'll be seeing that in IoT there are 2 people, in big data there are 4 people, in data science there are 4 people. So 4 plus 4 plus 8, total employees that are present over here is basically 10. Now one more way that I can basically apply a directly aggregate function also. Now see, these are all some of the examples, and again you can do different group by. Let me use df Pyspark. Suppose I say dot aggregate, okay, and inside this I will just give my key value pairs like this. Suppose I say, let me say that salary, I want to find out the sum of the salaries, the overall salary that is basically given to the entire total expenditure in short. So the total expenditure that you will be able to see somewhere around 73,000. All right. So we can also apply direct aggregate function. Otherwise, this all are also aggregate function which we basically apply after applying a group by function. Now suppose these are probably the salary. I want to find out. Suppose I'll take this example. I want to find out the maximum salary that the person is basically getting. Who is getting the maximum salary? Sorry. So here, instead of writing dot sum, now I'll write max dot show. Now here you can see Sudhanshu is basically getting 20,000. Over here 10,000. Krish is getting 10,000. Mahesh is getting 4,000. Right? So all this particular data is there. See, Krish is basically getting with respect to data science over here 10,000. So it has basically picked up. It is not picking up both the records, but at least when it is grouping by name, and then it is showing this particular data, that time you will be able to see it. Let's see whether I'll be also able to see this or not. So group by, if I go and write min, so here you will be able to see minimum value with respect to different records when I'm grouping by. Here you'll be able to see that Sudhanshu is getting a minimum salary of 5,000, 2,000. Krish is getting a minimum salary of 4,000. Right? We can also get that particular information. Now let's see what all different types of operation are there. Average is also there. So if I write AVG, it's just like mean only, guys. So this is basically the mean salary that probably you are getting. Again, you can check out different functionalities. Why these all things are basically required. Understand one thing is that you really need to do a lot of data pre-processing, a lot of retrieving skills that you basically do. You can check it out, this one, and you can do different functionalities as you like. Spark Mlib also has an amazing documentation with respect to various examples. So here you can go and click on examples and basically check out this particular documentation. You can actually see different kind of examples, how it is basically done. But with respect to Spark ML, there are 2 different techniques. One is the RDD techniques and one is the Dataframe APIs. Now what we are going to do, guys, Dataframe API is the most recent one, and it is pretty much famously used everywhere. So we'll be focusing on Dataframe API. That is the reason why we learned Dataframe in Pyspark very much nicely. So we'll try to learn through Dataframe APIs, and we'll try to see the technique how we can basically solve a machine learning use case. Now let's go and see one very simple example, guys, and always remember the documentation is pretty much amazingly given. You can actually check out over here and try to read all these things. Okay, so let's proceed and let's try to see what all things we can actually do. In this particular example, I'm just going to take a simple machine learning problem statement. So let me just open a specific data set for you all, and then probably we'll try to do it. Okay, so this is my data set, guys. I know there are not many records over here. Okay, so I have a data set which has like name, age, experience, and salary. And this is just a simple problem statement to just show you that how powerful Spark actually is with respect to an Mlib library. It's just to show you a demo. From the next video, I'll be showing you detailed explanation of the regression algorithms, how we can basically do the implementation and all. Theoretical and all, guys, I have already uploaded. You can see over here. I'll be doing, see, after this tutorial 5, this is basically the tutorial 6. I'll try to add it after this. And then whenever I will be uploading the linear regression algorithm, before that, please make sure that you watch this maths intuition. Okay, I've uploaded this specific video also in the same playlist. So after this tutorial 26, see why it is saying tutorial 26, because I have also added this in my machine learning playlist. So after this, you'll also be able to find out when we'll be discussing about linear regression, how we can implement in depth. That video will also get uploaded. So let's proceed. And here is my entire data set, guys. This is my data set. Now what I have to do is that based on age and experience, I need to predict the salary. Very simple use case, not much data pre-processing, not much transformation, not much standardization and all. Okay, I'm just going to take up this 2 independent feature, and I will be predicting the salary of this particular person based on age and experience. Okay, so this is what I'm actually going to do. So here is a perfect example. Again, detailedly, I'll try to show you how to basically implement line by line, probably from the upcoming videos where I'll be discussing about linear regression and all. And if I go see this particular problem, this is also a linear regression example. Okay, so let's go over here. First of all, as usual, I will be creating a Spark session. So I'll use from pyspark.sql import Spark session, and then I'm going to use spark session.builder.app name. Here I'm actually creating a Spark session of missing. Let me execute it. I think this is pretty much familiar. You're familiar with this. Then what I'm going to do over here is that we are just going to read this particular data set with test1.csv. Header is equal to true and infer schema is equal to true. So when I go and see my training.show, these are all my features over here. Perfect. I'll be giving you this data set also, don't worry. Now from this particular data set, if I go and check out my print schema, so here you'll be able to see that I'm getting this particular information. This is my entire print schema over here. I have features like name, age, experience, and salary. Now if I go and see training.columns, this is my training.columns. Now always remember, guys, in Pyspark we use a different funda or mechanism or a kind of data pre-processing before. See, usually what we do is that by using machine learning algorithms that are available in scalar, we basically do a train test split, right? And then we first of all divide that into independent features, dependent features, right? Which we use an x and y variable, and then we do train test split by doing this. In Pyspark, we just do some different techniques. What we do is that, yes, we have to basically create a way where I can group all my independent features. So probably I'll try to create a vector assembler. We basically say it as a vector assembler. See over here the class I have actually used. The vector assembler will make sure that I have all my features together grouped like this, in the form of age and experience. Suppose over here my 2 main features are age and experience, which are my independent feature, right? So it will be grouped like this. For every record it will be grouped like this. Okay, for every record it will be grouped like this. And then what I will be doing is that I will be treating this grouped as a different feature. So this will basically be my new feature, right? And remember, this new feature is my independent feature. So my independent feature will look like this in a group of age comma experience, which will be treated as a new feature, and this is exactly my independent feature. So I have to group this particular way. So in order to group this, what we do is that in Pyspark we use something called as vector assembler. So in this vector assembler, it is basically present in pyspark.ml.feature. We use this vector assembler. We use 2 things. One is input column, which all column we are basically taking to group it. So 2 columns, one is age and experience, right? We don't have to take name because name is fixed. It is a string. Yes, if category features are there, what we need to do, we will convert that into some numerical representation. That I'll be showing you when I'm doing some in-depth implementation in the upcoming videos of linear regression, logistic regression and all. But here you'll be able to see that I'm going to take input columns, age comma experience in the form of a list, and then I will try to group this and create a new column which is called as independent feature over here, right? That is what I'm actually doing. So if I go and execute this vector assembler, so here I'm got my feature assembler, and then I do dot transform. I do dot transform on my training data. So this is basically my training data. When I do this and when I do output dot show, here you'll be able to see I had these all features, and a new feature has been created which is called as independent features. Okay, so we have actually created an independent feature, and you can see over here age and experience, age and experience, age and experience. So this is my grouped rows that I've actually got. In short, what I've done, I've combined this two column and made it as a single independent feature. Okay, now this will be my input feature. Okay, and this will be my output feature, and we'll try to train the model. Okay, so over here now, if I go and see output dot columns, I have name, age, experience, salary, independent feature. Now what I'll do out of this, let's take which all data set I'm actually interested in. So out of this, I will just be interested in this two data set, right? Independent features and salary. Salary will be my output feature, the Y variable, right? And this will be my input feature. So what I'm going to do, I'm going to select output dot select independent features and salary, and I'm going to put that in my finalize underscore data. That is what I'm actually doing. If I now go and see my dot show, here you'll be able to see the entire thing. Now these are my independent feature, these are my dependent feature. Now the first step, what we do a train test split, like how we do it in sklearn. So in order to do a train test split, I use a function inside my finalized data which is called as random split. Remember guys, I'll try to explain you line by line by implementing it when I'm doing a bigger project. Right now, since this is just an introduction session, I really want to explain you how things are actually done. So this is basically my train test split. So here let me write it down, the comment train test split, and I will be using the linear regression, like how we import a class from sklearn. Similarly, by using pyspark.ml.regression, import linear regression, and then I'm doing a random split of 75 to 25%. That basically means my training data set will be having 75% of the data, and my test data set will be having 25% of the data, right? Then after that, I'll be using this linear regression. In this, you have two important variables that we need to give. One is feature columns. How many number of feature columns are there? That is completely present in this independent feature. So I'm giving it over here. Similarly, in label column, this is my second feature that I have to give. This is my output feature. So after I provide both these things and do a fit on train data, I will be able to find out my coefficient. These are my coefficients. These are my intercepts. And here I can now evaluate and see my output, right? So by using this evaluate function, we will be able to see the output, and inside this there will be a prediction variable which will have the output. Okay, so this is my prediction, this is my salary, the real value, this is my other thing. Now if I really want to find out the other important parameters or metrics, let's press tab. Here you'll be able to see mean absolute error, spread underscore result dot mean squared error. Suppose if I do see this particular word value, you'll be able to understand that how the model is actually performing. So that's just a very simple example, guys. Don't worry, I'll be explaining you in depth probably in the upcoming videos when we'll be starting from linear regression. Now remember, the next video is about linear regression implementation, in-depth implementation, right? To help you know what exactly is a Databricks platform. And this is an amazing platform where you can actually use Pyspark, or you can work with Apache Spark. And one more amazing thing about this particular platform is that they also provide you cluster instances. So suppose if you have a huge amount of data set, probably you want to distribute the parallel processing, or probably you want to distribute it in multiple clusters, you can definitely do with the help of Databricks. Now if I really want to use this particular platform, there are two ways. One is for community version and one is for the paid version, which is like Azure or AWS cloud you can actually use in the backend. Databricks also helps you to implement ML flow, okay, and this ML flow is with respect to the CI/CD pipeline, so you can also perform those kind of experiments also. Altogether, an amazing platform. What I will be focusing in my YouTube channel is that I will try to show you both with the community version also, and in the upcoming videos we'll try to execute with both AWS and Azure. When we are using AWS and Azure, what we'll try to do is that whenever we create the instances, multiple instances, that we'll try to create in this particular cloud platform. We'll also try to pull the data from S3 bucket, which is the storage unit in AWS, and try to show you that how we can work with huge data sets, right? All those things will be actually showed as we go ahead. Now let's understand what this Databricks is. It is an open and unified data analytics platform for data engineering, data science, and machine learning analytics. Remember guys, Databricks actually helps us to perform data engineering. When I say data engineering, probably working with big data. It also helps us to execute some machine learning algorithms, probably any kind of data science problem statement we'll be able to do it. And probably it supports three kind of cloud platforms. One is AWS, Microsoft Azure, and Google Cloud. Now, if you really want to start with this, we'll start with the community version, and you just have to go into this particular URL and just type try Databricks, and then you just enter all your details to get registered for free. Now, once you are registered, once you get started for free, you'll get two options over there. On the right hand side, you'll be seeing the community version, which you really want to use it for free, and in the left hand side, you will be having an option where they'll tell you that you need to work with these three cloud platforms, and you can select that also. So for right now, I will try to show you a community version, which will be very simple, very easy. So let's go to the community version. So this is how the community version actually looks like. If you really want to go into the cloud version, you can just click on upgrade. Okay, so just click on upgrade, and this is the URL of the community version, and this URL you'll be able to get when you register for the community version. And tomorrow, so you think that you probably want to work with the cloud, you just have to click on this upgrade now. Now in this, you'll be able to see three things. One is explore the quick start tutorial, import and explore data, create a blank notebook, and many more things. Over here, what all kind of tasks you'll be able to do in the community version. One is you can create a new notebook, you can create a table, create a cluster, create new ML flow experiments. I hope I have actually showed you ML flow experiment. We can also create this ML flow experiment by combining to a database in the backend. Okay, then we can import libraries, read documentation, do a lot of tasks. Now first of all, what we need to do is that probably I'll create a cluster. Now in order to create a cluster, I will click on this create a cluster. Here you can basically just write down any cluster name. Suppose I'll say Apache or I'll just say Pyspark cluster. Suppose this is my cluster that I want to basically create. Okay, and then here by default over here you can see 8.2 Scala. This one Spark 3.1.1 is selected, so we will be working with Spark 3.1.1. If you remember, in my local also I actually installed this particular version only. Okay, by default you will be able to see that they will be providing you one instance with 15 GB memory and some more configuration. If you really want to upgrade your configuration, you can basically go and click over here. Okay, and remember in the free version you will be able to work in an instance unless and until it is not idle for 2 hours, otherwise it will get disconnected. So over here you can see one driver, 15.3 GB memory, 2 cores, and 1 DPU. Okay, all these things are there. You can also understand what DPU is. DPU is nothing but a Databricks unit. If you want to click over here, you'll be able to understand what exactly DPU is. Okay, and you will be able to select a cloud and basically work with that. Perfect. Till here everything is fine. Let's start. Let's create the cluster. Now once you will be seeing that the cluster is basically getting created, you also have a lot of options over here like notebook, libraries, event logs, Spark UI, driver logs, and all. It's not like you'll be able to work with Python over here. Here you have a lot of options. Okay, so suppose if I go and click on libraries, and if I click on install new, here you will be having an option to upload the libraries. You can also install the libraries from PyPy, from Maven, which we basically use along with Java. Then you have different workspace. So here what I'm going to do is that suppose if you select PyPy and suppose you want to install some of the libraries like TensorFlow, or probably you want to go with Keras, you can basically write like this. Probably I want sklearn, so I can just give comma separated and start installing them. Okay, but by default I know I'm going to work with Pyspark, so I'm not going to install any libraries. So let's see how much time this will probably take. This is just getting executed over here, and let's go back to my home. So apart from this, here you'll be also able to upload the data set, and that particular data will give you an environment like how you're storing the data in the Hadoop. Okay, so before the cluster is getting created, okay, now the cluster has got created. Here you can see Pyspark, it is in running state now. And remember, this cluster only has one instance. If you want to create multiple clusters, we have to use the cloud platform one, which will be chargeable. Okay, so here I'm going to click on export the data. Now see guys, you can upload the data. You can also bring from S3 bucket. Okay, you can also then bring from S3 bucket. These all things I'll try to show you. Then you also have dbfs, you know, and dbff you will basically be storing inside this particular format. Then you have other data sources like Amazon Redshift, Amazon Kinesis. Amazon Kinesis is basically used for live streaming data. Okay. Then you have Cassandra. Cassandra is also a NoSQL database. Then JDBC, Elasticsearch. So different data sets, data sources are also there. We'll also try to see with respect to partners integration. So they are also like real-time capture, data lake, and many more things are there. So you can definitely have a look onto this. Now what I'm going to do is that I'm just going to click over here and try to upload a data. Let me just see. Let me just upload a data sets. I'll just go to my Pyspark folder. So here is my Pyspark folder. I'm just going to upload this test data set probably, or I'll try to upload this test one. Now here you can see that the data set has been uploaded. Now it is saying that create table with UI, create table in notebook. Suppose if I go and click this, you know, so here you will be able to see this is the code. This is the entire code to basically create a table in the UI. But what I really want to do is that I don't want to create a table. Instead, I'll just try to execute some of the Pyspark code which we have already learned till now. Okay, so what I'm going to do, I'll just remove this. I don't want it. I'll remove this. Okay. Okay, let me read the data set. Now for reading the data set, over here you'll be able to see that my data set path is basically this. It is a CSV file, infer schema, header schema, all these things are there. So let me remove this also. So let me start reading the data set. So by default Spark is already uploaded. So I'll write spark dot read.csv. I hope so it will work. And for the first time, remember, this is my file location. File location. Okay, file underscore location. And then I will also be using two more options. One is header is equal to true, and then I have infer schema is equal to true. So once I execute this, now you will be seeing that automatically the first time when you're executing, it will say that launch and run. So we are going to launch the cluster and run it. So I'm just going to click it. Fail to create, reject requests since the total number of nodes would exceed the limit 1. Why this is there? Let's see our clusters. We just have one cluster. Okay, there were some examples that have been taken over here. So let me remove one of them. Okay, let me just execute this. Okay, I'll go over here, space, let me delete it. Okay, perfect. Now I'll try to read this. Let's see. Again it says fail to create the cluster, request rejected since the total number of nodes would exceed the limit of 1. I think it is not allowing us to execute more than one file, I guess. So because of that I'm just reloading it. Let's see now. Now it has got executed. See guys, before there were two files, so because of that it was not allowing me to run. I just I deleted one file and I reloaded one file. Okay, so now you can see that it is getting run now. Okay, you can also press shift tab to basically see some hints and all, same like how we do it in Jupyter Notebook. Now here you'll be able to see that my file will be running absolutely fine, and it shows this df, it shows that okay, it is a pyspark.sql.dataframe.dataframe. Now let me just execute the other things. Now suppose if I want df.print, see I'm just using that tab feature, print schema. If I go and see this here, you'll be able to find out all the values, right? So in short, this is basically now running in my instance of the cluster, right? I will be able to upload any huge data set, probably a 50 GB data set also from S3 bucket and all, right? That I'll try to show you how we can do it from S3 bucket in the upcoming videos. But what I'm going to show you guys in the upcoming future, we'll try to run all this kind of problem statements through the Databricks so that you'll be able to learn it. Okay. Now let me just go and do one more thing. So this is my df.show. Okay. So this is my entire data set. So probably I will just want to select some column. I can actually write this df.select, and here I just want to say salary.show. I'm just selecting salary.show. Here you'll be able to see. So everything that you want to do, you'll be able to do it. And remember, over here you'll be able to find out around 15 GB, and you can definitely perform any kind of things. Okay. Here also you have same options like how we have it in in Jupyter Notebook. Every option is there. You'll be able to find out all these particular options in Jupyter Notebook also, right? So this is basically running in 15.25 GB, 2 cores. Okay, in that particular cluster you have 2 cores. Then you have Spark 3.1.1, Spark 2.12, and you'll be able to see all this particular information. So what I would like to want, guys, please try to make a specific environment for you, and then try to start it. Try to keep everything ready, and from the upcoming videos we will try to see how we can execute, how we can implement problem statement, how we can implement different algorithms. Now, I have already given you the introduction of Databricks in the last class. I hope you have made your account, and I hope you have started using it. If you don't know how to make an account, please watch the tutorial 7. The entire playlist link will be given in the description. Now this is my Databricks community account. Remember, in the community version we can only create one cluster. I'll also be showing you in the upgraded versions. Probably in the future I'll be buying it, and I'll try to show you how you can also create multiple clusters, unlimited clusters. But for that you also need to use some clouds like AWS or Azure. Now first of all, what dataset I'm going to use. So this is the entire dataset that I'm going to use, guys. This dataset is called as tips dataset. So that basically means people who are actually going to the restaurant, what tip they have actually given based on the total bill. Or I can also go and solve this particular problem based on all these particular parameters. What probably is the total bill that the person is going to pay. Okay, so this is the problem statement that I'm going to solve. Now here you can see this is a multilinear regression problem statement. Here you have many features, right? So let's proceed. Now first of all, what I'm going to do, I'm just going to click to the browse, and I'm going to upload this particular data set. Now in order to upload this particular data set, I have this particular data set in my path. So probably I'll also be giving you this particular data set, so don't worry about it. Let me just quickly, just a second, let me just upload the data set over here. Okay, Pyspark. Okay, so here you can see that this is my data set which I'm actually uploading, tips. So let me open it. Right now here you'll be able to see that your tips data set will get uploaded in this dbfs directory. So here you'll be having something like file stores / tables. Okay, now what you can actually do now, let's go and click on this dbfs, and here you can see on file stores. Probably you can also click on tables. Here you have this tips.csv. I have also uploaded these all data sets in my previous videos. Probably I was just using this. Okay, but here I'm just focusing on tips.csv. Now what I'm going to do over here, let's go and do the first step. Remember, the first step in Databricks is that we need to create the clusters. Okay, create a cluster. Right now by default in the community version, Databricks actually helps you to create a cluster, just one single cluster. Okay, but if you are using the paid version, the upgraded version, it will actually help you to create multiple clusters if you have the access of AWS cloud. So I'm just going to click on the cluster. Let me create a new cluster. So I'll say this is my linear regression cluster. Okay, and then I'm going to use this runtime 8.2 Scala. This is there. I'm just going to click the cluster, and remaining all things will be almost same. In this cluster, in this instance, you'll be getting 15 GB memory and all the other information here. You can check it out. You can also be getting 2 cores and 1 DBU. Okay, so which I've actually already discussed in my previous session. So I'll go and click on cluster. This will take some time. And remember, guys, if you really want to use any kind of libraries, just click over here, install those libraries which you want. Like suppose if you want to use Seaborn, you want to use Keras, you want to use TensorFlow. So here you can basically type this along with the versions, and you'll be able to install it. Okay, but right now I don't require any libraries. I'm just going to use Pyspark. That is my main name. So guys, click on the clusters over here, and here you can see that probably after a minute this particular cluster is actually created. Okay, now again go to the home. What you can do, you can create a blank notebook. I've already created one notebook so that I have the basic code written. So I'm just going to open this, and let's start this particular process. Now first of all, I have something called as file location. I know my file location is basically tips.csv. The file type is CSV, and then I'm just using spark.read.csv. File location header is equal to true, info schema is equal to true. and let me just write df.show. This will actually help me to check the entire data set. Okay, so I'm just going to execute it in front of you, and let's make it line by line. I'll try to write down all the codes. It will definitely be helpful for you to understand. So please make sure that you also type along with me to understand the code much more better. Okay, so here now I'm going to execute this. Now here you will be able to see my clusters will start running. Okay, and then you can see waiting to running the command. Probably we will be able to see it. I'll just zoom out a little bit so that you'll be able to see properly. And again guys, for the first time, if you're starting this particular cluster, it will take time. Okay, so Spark job, it is running, and now you'll be able to see my data set. That is my tips data set, which is uploaded in this specific file location. So this is my entire data set: total, bill, tip, sex, smoker, day, time, size. Perfect. Now let's go to the next step. What I'm going to do, I'm just going to write df.print schema. So I can also use tab, it will be able to load this entire thing. So now here you can see that this is my entire features: total, bill, tip, sex, smoker, day, time. So here is all your features like double, sex is string, smoker is string, day is string, time is string, integer. Now remember, you may be thinking, Krish, why I am actually doing this in Databricks? To just make you understand how this will basically run in the cluster. Right now I just have one single cluster, guys. That basically means that the maximum RAM in this particular cluster is somewhere around 15 GB. But just understand, if you're working with 100 GBs of data, then what happens, this kind of processing will get split in multiple clusters, right? So in this way, you'll be able to work with big data also in the upcoming things, right? Now this is our thing, guys, right? Now let's go and try to understand over here, which is my independent feature. My independent feature is my tips feature, sex, smoker, day, time, and size. And my dependent feature is basically total, bill. So based on all these particular features, I really need to create a linear regression algorithm which will be able to predict the total, bill. So let's go ahead. Now over here, I'm just going to write df.columns. So if I want to check my columns, this is my columns over here. So I can see this is my exact columns. This many columns I actually have. Now, one thing about this particular feature over here, guys, you have columns like sex, smoker, day, time, right? These all are categorical features, right? And probably, this categorical features needs to be converted into some numerical values. Then only my machine learning algorithm will be able to understand it. So let's see how to handle category features. So here I'm just going to write a comment. Okay, handling categorical features, right? Now I'll try to show you how to handle this kind of category features. Now one way in Pyspark, and obviously we know in normal sklearn, we try to use one hot encoding, we try to use ordinal encoding, we try to use different kind of encodings in this. And similarly, we can use that same encoding over here also with the help of Pyspark. So for this particular process, we have something called a string indexer. So I'm just going to say from Pyspark, from pyspark.ml.feature, okay, I'm going to import something called as string indexer. So I will be using this string indexer. This string indexer will actually help us to, basically convert string category features into some numerical features. Numerical features basically is ordinal encoding. Like suppose if I have gender like male or female, it will be shown as zeros and ones. And over here you will be seeing, guys, most of the categories over here are ordinal encoding. Now you may be thinking one hot encoding, what is the process? That I'll try to show you in the upcoming videos with different machine learning algorithm. The reason why I'm making it, because it is better to learn one thing at a time, right? So I'll try to show all those kind of examples also. Guys, now let's proceed and try to see that how we can convert this category features like sex, smoker, day, and time. Probably time is also a category feature. See over here. So if I see this all features over here, let me do one thing. Okay, let me just write df.show. So this is my entire features. Quickly, if I go and see, this is time is also a category feature. So quickly, let's go ahead and try to see how we can basically use this. Let me delete this thing also, or let me just write it once again. So I have actually, imported this library called a string indexer. Now what I'm going to do over here is that, let me write an indexer object saying as this, and I'll write string indexer. And here, first of all, I really need to provide which all are category features. Now remember, In this string indexer, if I go and press shift tab probably over here, you'll be able to see I have to give input columns. So let me press here. I have to give input columns and I have to give output columns. I also have options of providing input columns as multiple columns and the output columns as multiple columns. So let me try both the thing. Okay, so over here, first of all, let me try with input columns. So here in the input columns, I will provide my first value. Now suppose I want to really convert this sex column into my category feature. So here I'll write output column. Okay, and here I'll say sex underscore indexed. Now here what we are actually doing, guys, here I'm actually giving my sex column, and this sex column will be converted into an ordinal encoding with the help of the string indexer. Okay, now in the next step, what I'll do, I'll just write df. Okay, probably I'll just use df, or what I can do, I can just create another probably I can create another data frame. So I'll write df underscore r, probably, see, because I don't want to change that df and again run that particular code. Now I'll say indexer dot fit. Okay, so I can definitely use fit, and then I can use transform. So here also it is almost same like that only, guys. Fit underscore transform, and here also I'm going to use def. Okay, and then if I go and see df underscore r dot show, here now you'll be able to see that this sex column, one more sex underscore index column will be created, and it will have the ordinal encoded values in this particular column. So let's go and see this. So once I execute it, perfect, I think it is running, probably it will take time. Now here you can see that I'm having one more column which is called as sex underscore index. Wherever the female value is there, the value is 1. Wherever the male value is there, the value is 0. Right? So we have handled this particular column, and we have basically converted this category feature into the ordinal encoding. Now still we have many features. So what I'm going to do, I'm just going to use this indexer again. Okay, and probably I'm just going to write over here multiple columns I will specify. So first column I've already changed it, so I'm going to change this into something else. Sex, instead of sex it will become smoker. Okay, smoker. But I showed you guys, instead of writing input columns, now I have to write input columns, right? So in this multiple columns when I'm giving, so this is smoker, then I have one more feature. If I see day and time, day and time is more 2 features, so I'm just going to write over here day underscore. So guys, now how I've written smoker, day and time, similarly I will be writing 3 more columns over here. So the first column should be, because I'm going to create the ordinal encoding, and I probably create a new column over here. So this will be my smoker underscore indexed. Okay, I'll close the braces over here. My second feature will basically be day underscore indexed, right? And my third feature will probably be time underscore index. So here I'm just going to create 3 more features, and then I'm giving indexer.fit df underscore r. Okay, because now I have my new data frame, and then I'm going to say df underscore r dot show. Now once I execute it, guys, I hope it should not give us an error. Okay, it is saying that invalid param value given for param output columns could not convert class to store. So I have to make this as output columns. Okay, so that was the issue, right? So now you'll be able to see that it's executing perfectly fine. Now here you have all the features available: sex underscore index, smoker underscore index, day underscore index, and time underscore index. And all you can see over here is ordinal encodings like 0, 1, 2, right? And we have now converted this all string values into this kind of all category values that are available in this feature into numerical values. Now my model will definitely be able to understand. Okay, now we have done this, guys. Now let's proceed. What is the next step that we basically do, that we are going to discuss? Now the steps are pretty much easy because we have already created this specific data set. Now what we have to do is that there is something called as vector assembler. Now always remember, guys, in Pyspark, you know, whenever we have all this particular feature, we need to group all the independent features together and the dependent feature separately. Okay, so guys, we'll write from Pyspark dot ml dot feature. I'm going to import something called as vector assembler, right? So I'm just going to use this vector assembler. This will actually help us to group independent features together and the dependent features separately. So let me just go ahead and write vector assembler, and then I'm going to initialize this. The first parameter I have to provide is basically my input columns. Here my input columns, what all input columns I have, let me just see. Before this, let me quickly do one thing, is that let me make a cell. Okay, move a cell up, create a cell, or let me just remove this and probably just let me write df underscore r dot columns. Okay, so how many number of columns we have? So I have all my information with respect to the columns. So my input column over here, the first thing that I am definitely going to provide is my tip column, because tip is required. Tip is the first independent feature and it is a numerical feature. Then I have something like sex underscore indexed. Okay, so I'm just going to copy this, paste it over here, and this is my another input feature. And remember guys, we really need to follow the order. So now my third feature is basically smoke index, and before this also I can also specify size. Okay, so I will be specifying size, sex index, smoker index. Okay, and then probably I'll also create day index. Okay, day index, comma, I'm just going to use time index. Okay, so these are all my independent features. And with respect to this, now remember this will be grouped together, and I also have to say that if this is grouped together, let's create a new feature and name this entire group. Okay, so here I'm just going to say output column is equal to, and here I'm just going to specify these are my independent feature. So I'm going to name this entire thing as my independent feature. Pretty much simple. Now let me do one more thing. Let me create a variable called as feature assembler, so that we'll be able to transform these values. Okay, so feature assembler is equal to vector assembler, and here I have to provide my input columns and the output columns. Pretty much simple, pretty much easy. Now the next step that I'm going to do is that write output is equal to, I'm just going to say dot transform, because I really need to transform, and this needs to be transformed from my df underscore art. Okay, so let me just execute it now. Now here it has got executed. Here you can see the entire output, all these things are created. These are my independent features. Now in the independent, and why we need to create this independent features, that is the specification that is given in Pyspark. Always remember, we need to create a group of features in probably a list. All these independent features will be done together. Now if I go and see my output dot show, here now you'll be able to see, I will be able to see one more feature which has this, or let me just write output dot select, because probably all the features have been grouped together and it is very difficult to see all the features in just one screen. I'm just going to take this independent features and just click on dot show. Now once I do this, here you will be able to see all these particular features are there. Remember, this needs to be shown in the same order. The first feature is tip, then size, sex underscore index, smoker underscore index, day underscore index, time underscore index. So these are my independent feature. Now I just have one feature, and over here you'll be able to see that it is just having a list of all the features like this. And this is the first major step to create. Okay, now let's go to the next one. Now I know what is my output. Now what I'm going to do is that out of this entire output, if I go and see my output dot show, here you'll be able to see all the features are available, right, in output dot show. So here you'll be able to see all the features are available. Now you know which is your output feature, right? So this is my dependent feature and this independent features are my independent feature. So what I'm going to do now, I'm just going to select output, or I'll say this is basically my finalized data, and I'm just going to pick up two columns, that is output dot select, and inside this I'm just going to give my two features, which I'm going to say one is independent features. Okay, independent features. I hope that the name is right, otherwise I'll just confirm it once again. So let me click it over here, independent features, and one is total underscore bill. Perfect, comma total underscore bill. Okay, now if I just go and execute this, now I'm just picking up two features right from this. Now if I go and find out finalized data dot show, now I'll be able to see two important features, that is independent features and total bill. Remember, this is all my independent features and this is my dependent feature. This is very much simple. Till here, if it is done, guys, the next step is basically I'm just going to copy and paste some code. I'm just going to apply the linear regression. So first of all, from pyspark.ml.regression, I'm going to import the linear regression, and then I'm going to take this entire finalized data and then do a random split of 75 and 25%. Okay. And then in my linear regression, I'm just going to provide my independent features as my feature column. This is two parameters needs to be given in linear regression. One is feature column. Here I'll be providing independent features. The second one is basically total bill, which is my dependent feature. And now I will just do a fit on trained data. So once I do it, my regressor model will get created. And probably this will take time. Now here you can see all the information, amazing information you're getting with respect to train and test. Okay. And remember, guys, whatever group we have made this independent feature, this is in the format of UDT. Okay. You can see the full form of UDT. That is not a big problem at all. Okay. Now I have my regressor. So what I'm going to do, I'm just going to say regressor dot coefficient. Since this is a multiple linear regression, so I'm just going to use regressor dot coefficient, and these are all my parameters or different coefficients, because I have around 6 parameters. So these are all the 6 different coefficients. Always remember, in a linear regression, you will be having coefficient based on the number of features, and you will also be having intercept. So here I'm just going to say intercept. Okay, so this is basically my intercept, that is 0.923. Okay, so here you have both the information. Now it's the time that we'll try to evaluate the test data. So here I'm just going to say test, and this is basically my predictions, right? So here let me write it as something like this. So predictions, okay, prediction, and what I'm going to do, I'm just going to write pred underscore results. Results is equal to this one, and this will basically be my results. Okay. Test is not defined. Why test is not defined? Because this should be test data. I'm actually sorry. Okay, but it's okay. You will be able to get so small errors. Okay. Now, if I really want to see my pred results, just go and see pred dot predictions. There will be something like predictions dot show. Okay. If you write like this, here you will be able to get the entire prediction. Okay. So remember, in this prediction, this is your independent feature, this is your total bill, this is your actual value, and this is a prediction value. Actual value, prediction value, actual value and prediction value. Here you can actually compare how good it is, you know, by just seeing your total bill and the prediction value. Pretty much good, pretty much amazing. You are able to see the data. I'm just going to write my final comparison. Okay, final comparison. Perfect. I'm very much good at it. You can see it. Now let's see some of the other information, like what all information we can basically check it out from this. We have a lot of things, guys. Probably you want to check out the R square. So what you can write, you can basically write regression dot, if I press tab, this coefficient, intercept, then you have loss, then there's also something called as R square. If I go and execute this, this is basically my R square, or let me just write it down. I think the predictions, I don't think so. R square is where, let's see whether we'll be able to see the R square value or not. Just a second, I'm just checking out the documentation page. Okay. Oh, sorry, I don't have to use regressor over here. So here I will be using prediction.results, and let me compute the R square. So this is my R square. Similarly, you can also check out prediction results dot mean absolute error. So you have mean absolute error. You also have prediction underscore result dot mean square error. So all these 3 values you can definitely check it out. So here is your mean absolute error. Here is your mean square error. So these are my performance metrics that I can definitely have a look. And whenever you face any kind of problem, just make sure that you check the documentation in Apache Spark Mlib documentation. Now in this way, you can definitely do this entire problem statement. Now I'll give you one assignment. Just try to Google it and try to see how you can save this particular file, probably in a pickle format or probably in a temporary model pickle file. You know, it's very simple. You just have to use the regression.save, but try to have a look and try to see that how you can save this particular pickle file. Now this was all about this particular video. I hope you like this. Now just try to solve with any other problem statement. Try to do this. In the upcoming videos, I'll also try to show how you can do one-hot encoding and probably you'll be able to learn that too. So I hope you like this particular video. Please do subscribe to the channel if you're not already subscribed. I'll see you in the next video. Have a great day. Thank you and all. Bye-bye.